Morning, everyone. Right here in this video, we are going to review this week's IXL assignment of Z13, comparing linear functions, graphs, and equation with the shortcut code BQQ. All right, let's just go ahead and get started here. Function A and function B are both linear functions. So one is represented as an equation, the other is graphed for you. The first thing we need to do on this assignment is read our statements, because that is letting us know how we're comparing the functions. And I myself even made this mistake, and I assumed that the whole assignment had me comparing slope, and it doesn't. So when you get to a new question, always go down and read those statements to see what it is you need to compare with your functions. In this case, we are comparing slope. It says the slope of function A is greater than the slope of function B, or the slope of function A is less than the slope of function B. So one of these statements is going to be true, but either way, we need to find the slope of each function so that way we can compare them and determine which is the true statement. All right, with function A, with our equations, it's kind of nice because we don't actually have to do any math. We just need to look at the equation to determine the slope. Remember, when our equations are in slope-intercept form, that means it is y equals mx, struggling to write today, plus b, where the variable m represents our slope, which means when it's in slope-intercept form, the coefficient of our x, so the number being multiplied by x, is our m, our slope. In this case, let's change up the color here. In this case, that means our m, our slope, is 2. So for function A, the slope is 2. Not only am I going to write it here, but I'm also going to write it with my statements, because then when I read my statements, I remember function A has a slope of 2. So function A is 2, function A is 2. Now let's find the slope of function B from our graph. Remember, when we have a graph and we're trying to find our slope, we have to calculate it. So we have to count and see how much our y changes, so that's our rise, over how much our x changes, which is our run. So to find the slope from a graph, we're going to count rise over run, and that will give us our slope. All right, when I look in here, let's see, the graph has a y-intercept of -2, so that's where it begins. And that's where I always like to start with counting my slope. You don't have to start there. You can pick any 2 points on the line. I just like to go to the y-intercept because I'm a creature of habit. And then we need to go to the next point on the line. And the next point on the line is actually not very far away. It's right here. So my rise is 1, and my run is 1. So 1 divided by 1. Let's reduce that fraction. 1 divided by 1 is simply just 1. So the slope of function B is 1. And once again, I'm going to write that in my 2 statements here. So that way, when I read them, I can better determine which is correct. All right, the first statement. The slope of function 2 is greater than the slope of function B, which is 1. Well, is 2 greater than 1? Yes, it is. So this first statement is correct. Let's click on that and see if we're right. And we are. Let's try another example here. Let's jump up a level. All right, this is another type of question that you're going to get, and this is why I said you really need to read the 2 statements, because sometimes it's asking you to compare your slopes, but that's not the case in this one. If I read my two statements, the y-intercept of function A is either greater than the y-intercept of function B, or it is less than the y-intercept of function B. So now we need to find the slopes of each so we can compare them. All right, for function A, which is my equation, it's very similar to the last problem with slope, where I don't actually have to do any math. I just need to look at it and see what the slope is. When my equation is in slope-intercept form, y equals mx plus b, the m represents our slope, and the b, our constant, is what represents the y-intercept. Let's change up the colors again. So in this case, my b is a positive 2. So the y-intercept of function A is a positive 2. It's kind of funny. It's the same as the slope last time. All right, function B, we need to find the y-intercept from the graph. So the definition of a y-intercept is it's intercepting, it's crossing through our y-axis. So I'm going to highlight the y-axis right here. So here's our y-axis. So wherever my green line intercepts that, that's the y-intercept. And it intercepts the y-axis right here, which if that's between -4 and -6, that means it's a -5. The y-intercept for function B is a -5. All right, I have the information needed to compare, so let's read those sentences and see which is correct. The y-intercept of function A, which is 2, is greater than the y-intercept of function B, which is -5. Is 2 greater than -5? Yes, it is. So once again, this top statement is our answer. Very good. All right, guys, we are going to do one more example together. Let's jump up another level. All right, right here. So remember, our goal is to always get to a SMART score of a 60, because that is the minimum SMART score to get a passing grade in the grade book. It would be obviously great to get higher than that, but at minimum, we need a 60. All right, this time, which statement is true? The y value of function A when x is equal to -2. Ooh, this one's a little bit trickier. Because notice that it's saying y value. It's not saying y-intercept. So don't let that confuse you. It's saying, all right, when my x is -2, what's the other half of that ordered pair? What is the y value? And the way that we figure this out is different for each function. So we want to know what the y value is when my x is -2. So you're being told that your x is -2, which means your x doesn't have to stay a variable because you know its value. You know the value is -2, which means we're going to substitute -2 in for x, and that will allow us to find the y. All right, for function A, our equation is y equals, because I'm trying to find the y, so it stays a variable. But instead of 3 times x, it's going to be 3 times -2. Because we're told that our x value down here is -2. And that's the only thing that we're substituting, that we're replacing, so everything else stays the same. All right, y equals 3 times -2 plus 5. Now we just need to follow order of operations to finish solving this. All right, first would come multiplication. 3 times -2 is -6. and then plus 5. Negative 6 plus 5 is negative 1. So when x is equal to negative 2, my y value is negative 1. So the y value for function A is negative 1. Now let's find the y value for function B. All right, this is going to be a little bit faster because we have a graph. So I can, kind of like that vertical line test, remember how we would run the vertical line test to see if we had any repeating x's? I can run a vertical line through the x value of negative 2 and see where it hits and intercepts my graph. All right, so right here is x equals negative 2. And that intercepts my graph right here. And that ordered pair is negative 2. And then if it's between negative 6 and negative 8, negative 7. So for function B, when my x value is negative 2, my y value is negative 7. All right, we have the information we need to compare, so let's see which statement is correct. So the y value, so actually this is really wordy, so I'm just going to read the key points here. So negative 1 is greater than negative 7. Or negative 1 is less than negative 7. Remember with negatives, it's kind of that backwards thinking because if you think about money, you're going in debt. If you think and imagine a number line, you're going further and further to the left. So in the case of negatives, once again, the first statement is correct because negative 1 is greater than negative 7. Because if we speak money, if you owe someone $1, you have more value in your pocket than if you owe somebody $7. You're in larger debt, so you don't have as much money. All right, so I know on my examples, every single time it was the first option, but that's not going to be the case for you guys. It just was a weird coincidence here. And hopefully, this answers some of your questions, but if not, remember I have my help sessions every Monday and Thursday at 4 o'clock Eastern Standard Time, so please come to those and we can work on IXL together and I'll be happy to answer your questions. All right, bye guys.